74,000 years ago, on the Indonesian island now known as Sumatra, a volcano erupted with a force so extreme that geologists still use it as the textbook benchmark for the largest class of eruption a volcano can physically produce. What it left behind wasn't just a hole in the ground, it left behind a question that has quietly haunted anthropologists for 3 decades. Did this single eruption almost end the entire human species before our species ever really got started? For years, the answer most scientists gave was yes, and the evidence seemed to back it up in a way that felt almost too clean to be a coincidence. Then, over roughly the last decade, that clean story started falling apart, piece by piece, under exactly the kind of scrutiny good science demands. And the real story that's emerging now might actually be more interesting than the apocalypse it replaced. Before we get into what actually happened, if you're the kind of person who likes watching a scientific mystery get taken apart layer by layer, evidence for, evidence against, and the honest mess in between, go ahead and subscribe now, because that's exactly what we do here. Let's start with the eruption itself, because there's no controversy about this part. Roughly 74,000 years ago, the Toba volcano detonated in what volcanologists classify as a supereruption, discharging an almost unimaginable volume of magma and ash in a geological instant. What's left of the volcano today is Lake Toba, a body of water so large it's often mistaken for an inland sea when you first look at it on a map, stretching roughly 60 miles long and filling the collapsed caldera left behind after the eruption emptied out the magma chamber beneath it. Ash from the eruption has been found preserved in sediment layers as far away as India, over 1,000 miles from Sumatra, and traces of it show up in ice cores drilled from both Greenland and Antarctica, confirming that whatever happened at Toba, its physical debris genuinely did spread across the entire planet. Here's where the real story begins, though, because a volcano erupting violently is one thing. A volcano nearly wiping out an entire species is something else entirely. And that's the claim that turned Toba from a geological curiosity into one of the most debated events in the story of human evolution. If you look at the genetic diversity of every human being alive on Earth today, all 8 billion of us, and compare it to the genetic diversity found within a single, ordinary troop of about 50 wild chimpanzees, something strange jumps out immediately. Our species, despite our enormous population and the entire planet's worth of geography we're spread across, is genetically far less diverse than that one small group of chimps. For decades, that was a genuine puzzle in population genetics, and starting in the late 1990s, a growing number of researchers proposed a compelling explanation. What if, at some point in our species' deep past, the number of breeding humans on Earth collapsed down to a tiny fraction of what it had been? A population crash, severe enough to permanently narrow our genetic diversity going forward, the same way a small group of survivors starting a new colony will always carry less genetic variation than the larger population they came from. This idea became known as the Toba catastrophe theory, and the timing lined up in a way that seemed almost too perfect to ignore. Genetic studies of human population history kept pointing to a dramatic bottleneck in our species sometime in the deep Pleistocene, an era when our population may have shrunk to somewhere between 3,000 and 10,000 breeding individuals worldwide, and the timing estimates for that genetic bottleneck landed suspiciously close to the same window as the Toba eruption. The proposed mechanism made sense on paper too. A supereruption of that scale would have launched enormous quantities of sulfur dioxide and fine ash high into the atmosphere, and researchers modeling the aftermath suggested it likely triggered what's called a volcanic winter, a period of sharply reduced sunlight and dramatically cooler global temperatures lasting anywhere from 6 to 10 years, layered on top of a broader cooling trend that some estimates suggested lasted as long as a full millennium afterward. Picture the immediate aftermath. Crops and wild vegetation failing across huge stretches of the planet as sunlight dimmed, food chains collapsing from the bottom up, and early human populations, already thin and scattered across the landscape, getting hit hardest in exactly the regions closest to the eruption, throughout much of Europe and Asia. According to the strongest version of this theory, most non-African human populations were essentially wiped out entirely by the ensuing climate chaos and modern era. Humanity's entire genetic lineage survived through only a small number of isolated groups clinging on in parts of Africa, later expanding back out to eventually repopulate the whole planet. If true, every single person alive today would trace their ancestry back through an almost unbearably narrow bottleneck of survivors, a species that came within a hair's breadth of extinction because of one mountain, on one island, on one very bad day, roughly 74,000 years ago. For much of the 1990s and 2000s, that story became close to the accepted mainstream explanation, showing up in textbooks, documentaries, and popular science books as one of the more dramatic near misses in the entire human story. But here's the thing about a genuinely good scientific hypothesis. It It has to keep surviving new evidence, not just the evidence that inspired it in the first place. And starting roughly 15 years ago, that's exactly where the Toba catastrophe theory began to run into serious, mounting trouble. The first major crack came directly from archaeology, and it came from a site called Jwalapuram in southern India. Close enough to Sumatra to sit squarely within the region, researchers expected to be hit hardest by Toba's ash fallout and subsequent climate disruption. If the catastrophe theory was correct, you'd expect the archaeological record there to show a clear, sharp interruption, stone tool traditions vanishing abruptly, followed by a long gap before any new evidence of human occupation. Instead, when researchers excavated through the ash layer itself at Jwalapuram, digging through sediment laid down before, during, and after the eruption, they found something that flatly contradicted that expectation. The same basic stone tool technologies continued on both sides of the ash layer, largely uninterrupted, with no dramatic evidence of a population collapse or a sudden cultural break. People, it seemed, kept living there, kept making tools in roughly the same way, and kept going right through the supposed apocalypse. Follow-up studies at additional sites across northern and southern India reported similar findings, and the authors of one particular study put it about as plainly as scientific papers ever do, concluding that many forms of life appeared to have survived the supereruption just fine, directly contradicting the picture of widespread extinction and genetic collapse that the catastrophe theory depended on. The second major challenge came from an unexpected direction: climate modeling itself, the very science the original theory leaned on most heavily. A study published in the Proceedings of the National Academy of Sciences in 2021 used significantly more refined climate models than the original Toba research had access to decades earlier, and the results painted a far messier, far less globally uniform picture than the original doomsday scenario suggested. Yes, the models confirmed that large parts of the northern hemisphere likely did experience meaningful cooling, potentially as much as 4 degrees Celsius on average, a genuinely significant climate shock. But the same model showed that most of the southern hemisphere, including large parts of Africa, experienced little to no cooling at all. Rainfall patterns told a similarly uneven story. Some regions, particularly parts of Northeast Asia and the Himalayas, may have seen rainfall drop by as much as 40%, a serious blow to any population depending on it. But plenty of other regions across the globe showed essentially no meaningful change in precipitation whatsoever. In other words, instead of a single, planet-wide, multi-year volcanic winter smothering every human population equally, the emerging picture looks much more like a patchwork of localized, regionally uneven disruptions, severe in some places, barely noticeable in others. And then there's the genetic argument itself, the very foundation the whole theory was originally built on, which has also taken serious hits in recent years. More recent, more sophisticated analyses of human genetic history have increasingly suggested that our species' overall population had actually already been gradually declining for tens of thousands of years before Toba ever erupted, likely starting somewhere around 150,000 years ago and continuing to shrink slowly all the way through to roughly 30,000 years ago. If that longer, gradual decline is accurate, then the specific genetic bottleneck once blamed squarely on Toba may never have been a single, sudden population crash triggered by one eruption at all. It may simply be one snapshot within a much longer, slower demographic story that had very little to do with a volcano in Sumatra specifically. Some researchers now argue that the reduced genetic diversity researchers observe today is better explained by ordinary founder effects, the kind of gradual genetic narrowing you'd naturally expect as small groups of early humans repeatedly split off and migrated into new, isolated territories over tens of thousands of years, rather than requiring one catastrophic near-extinction event to explain it. Taken together, this growing body of archaeological, climatological, and genetic evidence has pushed a significant number of researchers who study this era toward a conclusion that would have seemed almost heretical to say out loud 20 years ago. The so-called Toba bottleneck, as originally described, may simply not have happened, at least not in the dramatic and species-threatening form the theory originally proposed. If watching a once dominant scientific theory slowly get dismantled by better evidence is exactly the kind of thing that fascinates you, hit that subscribe button because there's a genuinely important twist still coming in this story, and it's worth sticking around for. Now, to be completely fair to the researchers who originally proposed the catastrophe theory, and to the ones who still defend versions of it today, this debate is genuinely not settled science in either direction, and it would be misleading to pretend the critics have delivered some final unanimous knockout blow. Defenders of the original hypothesis have pushed back hard against the newer findings. They point out that the specific archaeological sites showing tool continuity, like Jwalapuram, represent only a handful of locations out of what would have been an enormous, geographically varied human range at the time, and that a genuinely uneven patchwork climate disaster exactly the kind the newer climate models actually describe, could very plausibly have devastated some regional populations catastrophically, while leaving others in less affected pockets relatively untouched. Which is a subtly different claim than a single, uniform, planet-wide extinction event, but still leaves room for serious regional die-offs that simply happen to miss the specific dig sites researchers have excavated so far. And there is still genuine scientific disagreement over exactly how severe the eruption's broader climate effects truly were, with some more recent volcanic reconstructions, suggesting the eruption occurred across multiple distinct phases spread out over tens of thousands of years, rather than as one single instantaneous event, complicating exactly how researchers should even model its short-term versus long-term climate impact in the first place. So where does that honestly leave us? Probably in one of the more useful, if slightly unsatisfying places a good scientific mystery can leave you. The Toba eruption itself, its raw scale, its documented ash fallout spread across multiple continents, its status as one of the largest volcanic events in the last 100,000 years isn't in dispute at all. What is now genuinely actively contested is whether that eruption came anywhere close to nearly ending our species, and the weight of newer evidence, archaeological continuity at multiple dig sites, more sophisticated climate modeling showing wildly uneven global effects, and genetic data suggesting a longer, slower population decline rather than one sudden crash, has been steadily shifting away from the dramatic near-extinction story and toward a messier, more regional, less apocalyptic version of events. That shift matters, because it's easy to assume that once a scientific idea makes it into documentaries and textbooks, it's essentially settled forever. The Toba story is a pretty vivid reminder that it isn't. Sometimes the evidence that originally built a theory keeps holding up under scrutiny for decades, and sometimes, like here, better tools, better dating techniques, better climate models, and more archaeological sites gradually reveal that an old dramatic story was actually simpler and scarier than the messier truth turned out to be. There's something worth sitting with in that, honestly. We like origin stories with a clean, dramatic turning point, a single mountain, a single terrible year, a species brought to the very edge of oblivion before clawing its way back. It's a genuinely great story. It might just not be entirely true. The more boring, more complicated version, where our ancestors' populations slowly rose and fell over tens of thousands of years due to a tangled mess of migration, climate shifts, and ordinary demographic pressures, doesn't make for quite as dramatic a documentary hook. But it might be a lot closer to what actually happened on the ground, or rather, on the ash, 74,000 years ago. If stories like this, watching the evidence itself change the narrative in real time, are the kind of thing you want more of, subscribe and stick around, because next, we're heading to Lake Toba's genetic cousin in this story. The mystery of exactly how small that founding African population really was before it repopulated the entire planet, and that one might surprise you even more than this one did.